Hi everyone and welcome back to a brand new playlist, and in this playlist we are going to cover Prisma ORM. It's not an independent playlist. We are already talking about Node.js ORM, so it's a, you can say, sub playlist because we have already covered type ORM, Sequelize, Next, MongoDB, and then Mongoose, and now we are going to talk about the Prisma. It's like a new ORM for the TypeScript Node.js, and it is getting very much popular. So let's explore this, and we will use this ORM in the microservice. Like we can build the REST API, we can build a GraphQL interface, and we will see how Prisma fit in that. Prisma can be integrated with the SQL database, NoSQL database. So we can try with the Postgres, we can try with the MongoDB, and let's see how it is going to work. So first of all, let's take a look on our agenda, like what all things is on the plan. So we are going to talk about a lot of things here. First of all, we will just talk about the introduction, then we will see how this Prisma is different from the type ORM, Sequelize, and all the other different ORMs which I have already covered in the playlist, because I have a master playlist which talks about Node.js different ORMs, and recently I have already covered Next as a query builder. Then we will talk about what is the different things you will see in the Prisma when you do a one application in the type ORM, one application in the Prisma. How the migration works in the Prisma CLI, how we build the schema, how we build the models, and how we run the migrations. And then most importantly, we can learn by doing things. So what we will do is, let's say we pick one simple application with the MongoDB and with the Postgres using Express and Nest.js. So you can say these are like four different applications: Express, MongoDB, Prisma, Express, Postgres, Prisma, Nest.js, Prisma, MongoDB, Nest.js, Prisma, Postgres. And then same we can do with the GraphQL interface, like we can use a Nest.js GraphQL, or we can use Apollo GraphQL server, and then we can see how Prisma fits in that, because Prisma is just an ORM layer. Now you can use either a REST interface or the GraphQL interface. The objective of using the Prisma is exposing the interface, so that exposing the models with the relationships and all, like if you are writing a RDBMS like Postgres, MySQL, then you will be defining the relationship between the different models, and then automatically using the Prisma generate commands, we will just generate the migrations. So there are a couple of advantages of using Prisma over other ORMs. There is always pros and cons, right? And Prisma provides a Prisma client. Through that, using that, you can actually do a lot of things like seeding the database, or it's like there are a lot of advantages of using Prisma that we will talk in the details. Then we can also create a full stack clone app. Let's say not pure full stack clone app. I already have a plan to cover the Uber Eats and Swiggy clone, Udemy clone, with all these new technologies which we are talking about. So we can just talk about Next.js application, the React one, Next.js application, which is using Prisma as a database and exposing the APIs for the server-side rendered interface. Okay, so all those things are in the plan. I'm not going to talk much theoretically, because now we can just get into the code right away. We'll just talk about introduction, the differences, and then start writing the REST API with the Express Prisma with simple Postgres or a SQLite, like in-memory database. If you don't even want to use right away the MongoDB or the Postgres, we can use SQLite, just a simple application. Then we will start with the Postgres or MongoDB. So let's see how it goes. I already have this code already available on the GitHub. This is the same playlist, same GitHub repository, where I'm covering, okay, with Next, with MongoDB, with Prisma, with Sequelize, with type ORM, and without ORM. Okay, stay tuned. I'm going to add more and more videos in this playlist, and one video means one end-to-end whole interface, whole APIs. Thanks everyone. Thanks for watching. If you like my videos, feel free to subscribe my channel. Hi everyone and welcome back. Welcome to the ORM world, and here in this playlist we are covering about all the ORMs, and currently I'm targeting the Prisma. So we are going to do a lot of hands-on with the Prisma, and like the starter app, the Prisma with the Postgres, MySQL, MongoDB, and the whole new things and everything about the Prisma we are going to cover in this section of this playlist. So first of all, the basic understanding, okay, what is the Prisma, how it is different from the ORMs which I'm already using, SQLized, type ORM, and the query builder, which is Next. Next is a query oriented, the SQLized, type ORM, Prisma, these are object oriented. SQLized doesn't have good enough support for the TypeScript. Type ORM is good enough for the typings, defining the models, doing the migrations and all. But what is different now with the Prisma? Why should I even choose Prisma over the other ORM and the libraries? So we are going to explore in this video what is the new thing here and what all things we are going to get. So Prisma comes with these three variants. I mean, forget about the Prisma Studio. You can also use some kind of a database client. Prisma provides you the connectivity with all different database, SQL or NoSQL database, right? Prisma provides us the Prisma client, and it provides robust mechanism for data modeling. Okay, we are not going to write a data models same as the type ORM with the TypeScript annotations and all. You just define the data models for in the Prisma schema, and then automatically it's going to generate the Prisma client for those kind of entities. I mean, let's not call it as an entity. Entity means we are using relational database, but it is true for the SQL or NoSQL, both kind of database. It supports all the technologies, like I will target more on the Nest.js and Express, but you can write the Next.js, Next.js API backend also with the help of Prisma client. Obviously the GraphQL can integrate with anything. It's just like another way of like exposing the APIs, either REST or the GraphQL based. Apollo is just another GraphQL platform. Happy.js is another popular framework of Node.js. So my target is Next.js and the Express apps with the Prisma. Okay, you already familiar with the repository which I am covering. So first of all, what we are going to look at? We are going to look at, okay, I know type ORM and I have covered a lot about type ORM videos with the Nest.js and Express. Now, what is different thing which Prisma is providing? Prisma is auto-generating the typings. Okay, you define the models. We will do this in hands-on. You create the models and you just do Prisma migrate dev. What it will do, it will look into your models, the relationship you have defined inside a models, and it automatically generates the Prisma client, because your APIs are going to use Prisma client to connect to your database. It's another ORM, object relational mapping, because the entities are represented with the entities and the models are represented with the object and classes, right? So what you will do, you will create the entity object and do call save, find many, insert, update, delete, select, all these kind of queries. You are not writing SQL queries. First of all, if you are writing a simple CRUD with 1 or 2 tables, do not use ORMs. You should be good at writing SQL. But if it's like a lot of aggregation you have to do, then it's obvious you can use the type safe ORM, type ORM, or the Prisma. Prisma provides lot more advantage, I will say, because I don't need to worry about migrations. I will just use Prisma migrate. It will generate my migrations based on the models I have changed. So let's say initially I created a user table. Okay, and then I decided, okay, I needed 2 more columns. I will again just execute Prisma migrate. It will create a new migration for me. How cool is this? In the type ORM, I mean, there is a DB sync utility which automatically generates the database tables from your entities, but not actual the migrations. You can create the migration template and then you have to write, okay, this column I have added in this table, and create this as a new migration, right? So let's deep dive into this. First of all, to make things familiar with everyone, what is Prisma? or particularly why we should use Prisma, right? It's all about Prisma is providing a single source of truth for database and application models. You are going to create a single application model, single schema file with the multiple models and relationships. It provides less boilerplate because it is going to put all these typings in the Prisma client, not in the code. Okay, healthy constraint. The relationships are like easy, the joins and all, thinking more in the objects. I mean, if I, from my first impression, since I started using Prisma, I feel like I don't have to struggle with the migrations. Second thing is, it is generating the Prisma client. Okay, so I will go one by one. I mean, just like a simple documentation which you can also go through easily. So the first thing you think about is a Prisma schema. Prisma schema is nothing but some kind of what do you call it? Some kind of a schema file which contains something like this. This is first thing which you should look into. Okay, let's say, and this Prisma client, it's like a Prisma schema which contains, okay, what is your database? Provider is a Postgres, MySQL, MongoDB, and what is your client? And then your models. Models are like simple objects, right? Simple classes. Okay, my model is a user. I do have a couple of attributes in email, name, role, blah, blah. Then I have another model, profiles. There is some relationship with the user and profile, and then the post and category. This is kind of schema you are building. What you will do is you will generate the client from this schema. Okay, so this is the schema you have created, right? You will just generate a Prisma client like this. Okay, before that, you will be actually, where is the Prisma migrate? With the help of Prisma migrate, you will actually create the database representation of your models. So when you do the Prisma migrate, it will actually create a SQL file for you, and it will also create the Prisma client. Okay, now if you see this Prisma client, this is nothing but, okay, you install the Prisma, and if you do, we will check what is inside this node modules client directory, because what we are going to do, it doesn't introduce the boilerplate code in your main source code. What it does is it creates the Prisma client, it creates the entities and all the classes, all the methods of the entities inside this Prisma client directory inside node modules. Okay, so you can create a Prisma client. So your APIs will use Prisma client to talk to the database. Okay, so it's like this. Okay, you are writing an Express or Nest.js app, you will be using Prisma client, and on top of that you will be doing query something like this, prisma.user.create. So this user is a model already defined. Okay, and this is, and what we are doing is Prisma generate. What Prisma generate will do, it will check your model, this model. Okay, there is a user model, and it will create the client. So Prisma client, what it is, this, it is auto-generated clients, auto-generated type safe database client. So where it is inside node modules. Okay, so I mean, there are a lot of theoretical aspects. Let's not go into there. We will do a simple hands-on, and we will see all these things live. Okay, so let's get started. What I will do is I will go into with Prisma, and I will go into the starter, and here I will just create my package.json. I mean, this is the first example, so we'll bootstrap everything from the very basic, and then I will start installing all the modules I need. So first of all, I need is Prisma and Express. These two modules I need, and I will also install all the dependencies, dev dependencies, which is all about, okay, we are writing TypeScript, types Express, types Node, Prisma client, all these things we can install. So I will install all the other dependencies. So what all other things we need? We will install all the dev dependencies, which is types node, and let's say ts node, which we are using for compilation, TypeScript, types express. This is pretty much types node, types express, ts node, and TypeScript. These all are my dev dependencies, and then we are good. We can start writing our code. So first of all, we will create the Prisma folder there. In all the Prisma project, you will see the folder, and inside this we will talk about schema.prisma. Let's create our first file. This is the schema we are creating. So it is schema.prisma, and here we will define our data models. Okay, if you just take a look on package.json, dependencies looks fine. We have Prisma. I mean, there is nothing like this. And then we go to schema.prisma. Okay, so what does schema contains? Schema contains, okay, what is the generator client? Okay, generator client is Prisma client.js, and then data source. Inside data source, we will define, okay, what is the database we are using. So here we have a couple of attributes. Let me just find any extension for the Prisma. So this looks a little fine. Prisma, okay, Prisma Insider. So I can get some autocomplete stuff running on the VS Code. Postgres SQL. Okay. And then your URL of the database. And how can we get the URL? We have to get it from the environment. And environment is like database URL. So we need to create a .env file where we can populate all these things. Okay, maybe now it is identifying. Data source DB, and here we will define our models. Okay, let's say the users, courses, post, school, university. Let's say I'm just defining one model, car owner, and then I will just put some stuff like, okay, ID is auto incremented. Okay, so after correcting couple of mistakes, it should be model, data source, and sometimes we get confused, okay, is it a JSON or something else, and we start writing colon and something like that, okay, something like this, and everything will break, right? So it's like some kind, not YAML, not JSON. You have to remember, okay, this is how you will write the syntax. Okay, consider like this. You can create a number of models. Okay, this is users ID, and here I will put couple of attributes. Let's say ID name, email, address. That's it. So I created two different models. ID is default auto incremented, which is an integer, and you can also have a UUID or something like that. So this is our Prisma schema. Okay, now next thing is create the source folder and bootstrap our simple express app with the TypeScript. So I just switched to that particular project so we can see things more clearly. Here schema.prisma, and it is looking for some environment, right? So we can create a .env. I mean, you don't need to use .env for that, because Prisma automatically fetches things from here. Let's say if I'm using this particular variable, and what I need to do for this variable is I need to use Docker Compose up, because we already have Postgres running. or I need to see if I need to stop something. Okay, and then with what we will do is we will just spin up the Docker Compose. We already have a Docker Compose up on the root folder. It will spin up the MongoDB and the Postgres because we are doing a demo with MongoDB and the Postgres, and I think it is creating both the database containers, and I already provided the environment variables, so it should be creating the database which I want. Creating database is, it is creating test database, right? And this is it, test database 5432. For that port I need to look into Docker Compose file. Just getting outside. And the port is 5434. We are good. Okay, I mean, now everybody is using Docker. We cannot just install Postgres and MongoDB on the local. Okay, so this is Prisma. We created a model. We have a Postgres up and running, same as the MongoDB, and this is the client, and these are the two models which we have. Now we can create a simple server.ts file. A minimal example, TypeScript code, which is nothing but going to start our application. So first of all, what we will do is we will import the Prisma client after generating it. Currently we haven't generated it, so it is Prisma client, import express from and then we will create a Prisma client object, const, let's say client equal to new, and here we are going to import Prisma client. Okay, and similarly we'll create express instance, a simple one, and then because here we are doing quick and dirty, we are just writing a simple API which async. Here we are just doing a request response, and we are going to get something, let's say in the payload. It's better if we can, okay, let's say request dot why it is complaining, because we have to use await in the body because this is a sync function and it is TypeScript, so either you use any or just defer them to the request and response. Okay, we'll get something in the body. Either we can create a simple post, app.post request.body. We'll get the data. So we got the data inside a body. Now you can wrap things inside a try catch. Okay, so here we'll stop here because currently we don't know what entities we have. So what we will do is, first of all, we have to generate the Prisma client entities. Okay, so if you go to node modules, Prisma, here we do see something, but currently we haven't written any model entity objects like the classes and all. So where those things will be coming from? Those things will be coming from once we create the client for it. So we have to add some npm scripts for that. Let's say npm scripts that will help us to create things for the Prisma. So package.json, First of all, we'll just introduce a couple of scripts, that is Prisma migrate, Prisma generate, Prisma migrate. So these three scripts okay, so we will use Prisma generate first. So let's see what it is doing. So it is picking the environment variable from .env, which is the database URL. It is loading the schema from the schema.prisma, which we have created, like there is a car models and the user, and then it is populating this inside this directory, node modules Prisma client. And after this, we can start using the Prisma client like this. And what it has done, if you look into this, we just called the generate command. Okay, so if you go to node modules and the Prisma, it has created the Prisma client for us. I mean, it was already there. Now it will be exposing. You can see this car owners. We didn't write it, right? Where it is coming from. It has populated those entities inside the Prisma client. Now we can just use the Prisma client and can access the Prisma client.car owners, Prisma client.users.find, Prisma client.car owners.find, save, insert, update, delete. All these things we can do. Okay, let's say, but we haven't created tables yet. So how can we do this? We can do this by calling the generate command. Sorry, the migrate command, because there is generate and then there is a migrate. Prisma migrate, you can put some name. What it is doing is it is loading the environment variable, looking for the database, and then what it will do is we do have two models, right? Name is, let's say, the initial. This is the initial migration. It is going to create a single migration, migration.sql, and here you can see one single migration has been created, the SQL file, which contains the entities we have created. I mean the actual SQL which it has executed against Postgres to populate these two tables in the database, right? Car owner's key, the constraint it has added, the entities which are of type string, so it has converted that type to database type text. So what I did is I just executed the generate and the migrate. Generate will create a Prisma client, migrate will create the migration. It has created this migration based on the date stamp and the migration name, and this migration log file will contains which will maintain the track of all the migrations which you are executing. Now let's say I change the model. I introduce new column which is email, let's say first name, last name, and instead of this I will just call this as a first name. I mean indentation is a little poor here, we can live with that. Okay, now I will again execute Prisma migrate and I will give another name. Name will be update users, right? I have updated a columns in the user. So that was initial migration. Now I will be just using update underscore users, because I did update and it will create a new migration that will contain the update I have done. What I did is I introduced two new columns, you can see. So it is add new column, alter table users, add column first name, add column last name. You can also change the type, you can just introduce a new column, you can rename the column, you can create a new relationship. All those things you can do, and you just run npm run migrate. It will check the current state of the migration and what has been changed, and it will create the new migration. So I'm not writing any SQL query. I'm just updating the models, and based on that I can also, what I can do is generate. Prisma generate, it will look into the models, because whenever You change the models. It's good that you create you just generate the entities again, generate the models again. So it is going to synchronize our Prisma client. So if you just look into here, then I should be able to see whatever the new attributes I have populated. You can see the first name and last name is now available in the types which has been populated in the Prisma client. Now whenever I need to access the Prisma client, what I will do in our code, I already got it the client, right? So let's say it's just a simple code, client dot, what all you can access? The users dot. Now you can perform all different operations onto that. So like the Prisma client dot users, so let's say const users, and I'm going to, let's say, create users, right? So for the better, let's call it as a Prisma. So here I'm doing Prisma dot users. Let me just find the typings. Sometimes the typing is a little slow, it is trying to find it. Prisma.users, and now it will expose all the methods. Now if you just go here, okay, this is still loading, node modules, Prisma client. So if you just look into the users, because I'm going to the core of it, so you will see all the methods here. There are two models, Prisma.car owners, and here you will see all the methods which you can expose through the Prisma.entity name. Let's do the wild search. Alright, simply like fetch 0 or more users. What we are doing, Prisma.users.find many. Okay, if you wanted to create, what you will do is you will just call the same method of the Prisma. Do we able to identify? Now you can see get users, and I can see all the methods here. Count create. So inside a create, what you will pass? You will pass the entity, and inside a create you will pass the object of the user. And you can see this is how it is going to work. The sample, you have to pass the object. Let's say request.body. That's it. And then response.status 200.send users, or a single user, because we are creating a single user. A very simple example, right? Now if you encounter inside a catch block, then you will just simply return response.status 500.send.json .send null or something, whatever you would like to send. So what we are doing, we are creating the Prisma client, and from this Prisma client object you can access all the different objects. So there is another thing is car owners. Okay, you can call the create, update, delete, all the methods. Okay, that's it guys. Let's run this and see the output. So this is the TypeScript code we have written. We just starting the server onto a particular port, and this is TypeScript, so we cannot just do node index.js. We have to write our tsconfig.json file, and we have to define what we are going to do. I mean, when we are doing building, npm run build the TypeScript, what are the compiler options, what is the library, and what is the target. So when I do npm run build command is using tsc TypeScript npm run build. It should just generate the artifacts inside the dist folder. Npm run build, and remref command not found. We can simply do rm -rf. We should not use it because it's OS dependent. For now it will work. Run Start. On port 3000. So before looking into the actual API, there are other commands which you can do is npm run status to know the migration status. Npm run Prisma migrate, Prisma format. Let's just do the formatting. Generate and migrate command we have already seen. This is another thing is you can also check the status of the migration, Prisma migrate status. So these are all the migrate utilities like Prisma migrate status, Prisma migrate format, Prisma generate, Prisma status, and you can also create a new migration. I mean, using just dash name by passing the argument. Okay, now let's run the application. Here we are doing HTTP post. So I know there are a couple of things, but we will fix them while running the application. I mean, I did those mistakes intentionally so that we can fix them later. It is starting the application. We have to do a couple of code changes. So it's better that we can use node.js so that we can watch all the changes happening in our code and application gets restarted automatically. So node.js, here I can use node.js script that is already there. So instead of this, let's use npm run dev, and it will use node.js and it will start my application. Let's go to our code, very simple one. Here prisma.users.create is a promise. So first of all, we have to await, and then we are extracting things from the request body, right? If we are doing this, then we have to use the body parser, and with the express latest version, we don't need to use body parser. We can just use app.use express.json. And then we can use, these are the two middlewares which you have to add, express.url and code, and you should start getting the data from the request.body, right? Okay. Now this is our server, everything is good. We should be able to create it. This is the syntax of create, and let's get our application running, and then we can pass all the required attributes. I think most of the things are optional. Just hit the send and you will get the ID, and it is auto incrementing. So it's like a simple, very simple example. I should not spend that much time in writing this, but I went slow just to explain you all the things. Let's say if you are not using the body parser, then obviously you will get an error because you are inserting null inside the record, which is not allowed. Okay, the very simple example, I will put this in the GitHub, so you can also play around with the npm scripts like npm run generate, npm run migrate, and create a new migration by changing the models. Hi everyone, and welcome back. Welcome to my YouTube channel, and in this playlist we are talking about Prisma, like how to do the migration, how to create migrations, how to generate migration, how to generate the clients, all these things. So this is the third video, and in the first video we just talked about a simple Node.js app, and we just try to create the users like this simple server.ts file. We just use prisma.user.create. So in this next video, we are going to understand the migrations and the models more, because what we are doing is we are writing a schema.prisma file. We are defining all the different models we need in the project, like user model, course model, student, university, all these different models. Okay, like if we talk about simple blog post application, then the post, comments, users, reviews, all these kind of models we have to define. Those will automatically gets converted into the entity classes, sorry, the database tables, and the client can also be generated for the same. So let's talk about a couple of examples. Let's say I'm going to create a model playlist, okay, like playlist track. These kind of examples we can talk about. Model playlist, and inside this model we can define all the attributes. Okay, let's say the id is int, and you will see that this is not nothing like JSON. It's a simple schema file and it has its own syntax. Okay, then we have, like, let's say description, which is of type string, and id, like how to define the columns, how to define the primary key. For that you have to make @id, and then the default is auto incremented. You can actually install this plugin which will help you with the syntax, because it's totally different syntax. Like earlier you might have written the type ORM migrations, type ORM models or entities, or the sequelized entities, but this is little different. Here we are defining the schema file. So this is auto incremented, description is string. Let's say I have a tracks in the playlist. So I'm going to create another model for that. So this is the playlist track of type array. Okay, that means I need another model, playlist track, and here you will define all the properties for it. Let's say id, and id is again int, default auto incremented. You can just copy and paste. Okay, and then all the other attributes, let's say I have added 8, and this is a timestamp column, so it will be date time. Okay, I also don't know the exact syntax, so I'm just using this plugin and it is helping me a lot. Let's say I have a playlist id. And how can we create the relationships? That's another thing now, because it's not like we are going to have only single table. There can be n number of tables, and there will be relationship like one to one, one to many, many to one, many to many. Okay, here we are going to have the playlist id as a foreign key in the playlist track. So how should we define it? Let's do that. So inside this we have a playlist, and this is pointing to the playlist entity, playlist model, and here we can define the relations. This is the relations and field. Okay, which field you are pointing to? So this field in this entity is referred with, here we can define the references, referred with id of the playlist table. Now our warning goes away, right? If I just remove this, and you see this, and it says that error validation failed, tracks in the model playlist. So it is actually expecting that you are going to define the relationship inside a playlist track. You can see that the correct message, right? Error validating field, the relationship field tracks on the model playlist is missing. Okay, so here we are defining the relationship. So what we are doing here is, the inside this playlist track, it is pointing to the playlist id. I mean, the playlist id is a foreign key in the playlist track, which is referred with the id as a primary key from the playlist model. Okay, now we can create another entity. Let's say model track, and here id is again auto incremented primary key, and I can have a name which is type string, and here I do have all these three entities, and here also I can have track id, let's say, which is int. I didn't specify the explicit relationship between this playlist track and the track. The only relationship we have is which is enforcing the integrity constraint. Okay, because this can have only the id of this playlist primary key, playlist table primary key. This is the id, and we do have playlist id as a column in the playlist track, which is actually a foreign key having relationship with the primary key of the playlist. Okay, now this is done. How we can do this? We can just use npm run prisma migrate, it will check the schema file loaded from the environment variable, and this is our database URL, and it is going to actually run the migration. Will generate the models in our table, and here you can, because I already have some data, do you want to continue? Yes. So it will just wipe out all the data, and this is asking me the name. Okay, it's, I can say, the initial migration, and then if I change anything, then it will create the new migration. And here you can see migration.sql file has been created, and there we will see what all tables we have. Okay, so we have table playlist track, and now this is the important part, with what kind of relationship we have, right? So inside playlist track, we added a constraint with on the playlist ID column that is referring to the playlist table ID, and this is like a primary key foreign key constraint we have added foreign key. Right now, if you change something, you run the migration again, it will automatically generate the new migration. And other commands which you already know, there is a Prisma generate, and Prisma generate is also another command which will generate the Prisma client with these entities. Okay, now let's see the another example. Let's say user blog post users, comments, reviews, all these kind of entity we are going to create as another example. Hi everyone, so let's take a look on another example. So I will just you can delete the migration because we are just playing around this. You can remove this schema, and let's create another thing. Here we are going to play a little bit around simple blog post kind of entities. Let's say I'm going to create a first is model user, and that contains the ID, which is int @ID, which is auto incremented @default, and default is auto incremented, and I have email, which is of string, and I can add the constraint here. You can see, I think it should be unique, and I have a role which is of type role, like if you have some kind of enum, right? So in that case, I can add a enum. Maybe there is some kind of a column where you wanted to create enum, so let's say enum role, and it has only two, user and admin. Okay, so now that really works. We have created role, and I have another is, let's say, ID email role. We have a name and this string which is nullable. If you see the question marks, that means that is nullable field. Okay, role name, and we can also have all the posts which you are going to write from the post entity, post model, and profile which you are going to add as another model. Okay, let's say first create a profile. So we are going to create model profile, and inside profile we have couple of things, which is nothing but ID. I mean, it's just like I just wanted to show the relationship. That's why I'm creating another model as a profile apart from user. Here we have a biography about the user, and then user, because profile is going to have a foreign key from the user entity. So how should we define this? User is of type user. Okay, it will have a relations, and here we will define the fields. Fields is let's say I'm going to have a user ID. So first of all, you can define that user ID here. User ID is of type int. Okay, so this is user ID column referring to primary key of the user table. Yes, so this is a relationship we have created. Now similarly I can create a model post. Inside post model, because here you can see the validation error because user is having relationship with the post, but post model is empty. We haven't defined the relationship there. So inside we can have id as auto incremented. That is first thing, and then we can define all the other like created at, updated at. This is of type date time, and you can also assign the default. Okay, what will be the default value? Default can be now. Now means the current date time. Okay, title is of type string, published is a boolean, that is boolean, and here you can also set default using annotations. Default false. So this is just like a Prisma schema model syntax, and we just need to follow the syntax how to write it. So I'm going to post, published is boolean, user is having the relationship with the user. So here we can say this is author, and we have a user id. Let's say this user id is integer. Give me a second. So if I just format this with the Prisma, okay, you can see the magic. I mean, when I did command shift p format with Prisma, it automatically adds the columns which I needed. Like in the post, I will need author. Author will have a primary key, foreign key. Author is of type user, which will have a relationship field here as a author id. Author id will be of type integer, having a reference with the user entity. Okay, and other relationships like what are the different categories of a particular post. So I can have another entity, let's say categories, and it is pointing to category, which is array. Okay, so you will be defining categories model now, simple. And this is having, so there will be like a post can have multiple category, and a single category can belong to multiple posts. So here we are talking about many to many kind of relationship. So one to many we have seen, a single user can have multiple posts. For that we have defined this, that author inside the post will be the foreign key. Author id will be the foreign key inside the post table, and single user can write a multiple post. You can see here. But let's say I'm also having categories. But if I do command shift p, okay, here I will create a model categories, model as a category, and I will just define primary key, auto incremented, and then maybe the categories like, okay, this blog is about JavaScript, Node.js, React, and all, the name of the category and the posts to which it belongs to. So now this is a many to many relationship. So here like relations, and we are actually specifying the reference, because in the case of many to many it always creates a new table. And the same relations we can add to the category, because single category will belong to multiple posts, and one post can have multiple categories. So you can see the relations references, and we already have an enum. Why it is not liking this? Okay, let's see. Parsing attribute relations on the fields. So here what we are doing is profile. Do we need this? Inside user we have profile, or we can mark it as an optional nullable field. Okay, so now we have all these categories, all these models defined. what will happen if we just run the migration? We should see all these tables created, I think, with all these relationships. So let's do npm run Prisma migrate. So it will just check your database is running, and if that database is running, then it will just open that up. It will run the migration. So we need to give the connection name. Before that, I wanted to open our database. This is our database URL. So I'm just trying to connect to the database, and then we will see the table structure and all if there is any. So this was our earlier database, and what I'm going to do is enter the name of new migration, which is, let's say, the users. Okay, it is synchronizing with your schema, and we will check our database now. And you can see we have all the new tables, the categories, the post, and category to the post. You can see this is many to many. Here you can see the category, the post, the profile has a user ID, which is the foreign key, and the user, which has a unique on the email and the primary key. Okay, so this is just about how we are running the migration. We will talk about one more example, and then we are good. Like we can actually do some real project where we can define these kind of Prisma models. We run the migration, generate the Prisma client, and do the actual APIs, like some kind of a blog application, some kind of actual real world application where you are doing insert, update, delete, find, running the queries against the Prisma client. So let's take a look on a little bit more complex example. Like I do have only two entities, users and the bank accounts. Okay, so I do have users, user entity, which is ID primary key, email is unique. I mean, we can also explore the couple of other options, like how to write all these things at the rate unique. And you can also pass, I think, some parameters to which particular. So this is a constraint name here, users dot unique emails. This is a constraint name. You are just specifying. Role is still fine, name we have, and here I'm going to associate this with the bank accounts. And I'm going to create another model, bank account. Okay, other than that, I mean, I always use a snack case for specifying the namings. So you can just follow the same, or you can follow one particular approach. Created date is date time, updated at is also again date time, and the default, you can specify default is now. Same with the updated at. I think there should be something like at the rate. No, that's it. There is there something like updated at. So whenever you update it, automatically it will populate that. Both are date time. Now you can also, let's say I'm defining this model, but I don't want it to use this particular table name. Here you can see all the table names are in the camel case, and you can also see same with the columns. You can specify the column names whatever you want, created underscore in the snack case, and here I can do the mapping. How can I do? So I think there is a map, and map will actually associate the naming conventions whatever we can follow. Okay, I wanted to map it with the users, or let's say more specifically account users, because users table I think we already have account users. Okay, now we can create another model. So here with this @map, we can do a lot of things like specifying the mapping of the entity, like what will be the name of the table here, that is the objective. Bank account, this is another model I'm creating. ID is auto incremented primary key. So I will remove everything here. The first thing we have is the account ID. An account ID is of type string, and this is ID, and the default is, here we are going to have a UUID. So I think there is a type UUID also there. Same as auto incremented integer. We have a user underscore ID, which is string, and here we are going to have a relationship with the user. User is of type user, and here we will define our relation with which field. So here, okay, I have a fields is user underscore ID. User underscore ID is a string. Okay, we can also set because this is a string, so we can set this is a UUID. Default is UUID. Okay, this is integer, so let's make it as a string also. We don't need auto incremented primary key. Now string neither is a built. Okay, S is capital. Now this is field is user ID, and we have references. This referenced with the user ID. This referenced with ID. I mean the primary key of the user table. And here you can also specify the on delete cascade option. I think on delete and on update. So on delete it should be cascade, and on update you can specify, I think, on delete cascade, and on update is, can we do this? If I specify on update, okay, yeah, I see all these options. Set null I wanted to do, and on delete cascade. That's it. So we added these actions. What will happen if the primary key is deleted, right? So we have a user, then I have a number int, and you can also specify the default values of any particular column. Let's say I wanted to initialize it with 1, that is an integer, and created at and updated at, these columns you can put on most of all these models, because these are the life cycle models. Keep track on your entity record creations and all. And here I can add the unique key constraint, because here you can see I can specify map index on what all columns you wanted to add an index, unique key constraint you wanted to add. So here I am adding that on the user ID and the number column. Okay, and I'm just going to map this constraint with some particular name, which is, let's say, the bank account dot user ID number unique. This is kind of constraint name I put, and then again last stage just add the map. I'm just mapping it with the bank user bank accounts. There can be a better naming for the tables. Yes, now we can just run it. I can just format this if anything is left. Okay, everything looks correct. Then we can just, what we can do, npm run prisma migrate, and it should be able to create the account users table and the constraint with these particular names which we have specified. Okay, so this is all about migration, how we are defining the relationships, creating the migrations, and populating things in the database, all different types: string, enum, number, date, time, how to define the primary key, foreign key relationships. Okay, how to define the unique key constraint. Okay, let's see the real application in the next video, guys. Stay tuned. So now we are going to, let's say, build a simple authentication system, and here we are going to do all the Prisma related APIs from the Node.js. Okay, let's see the migrations we have created, and this is the table structure. We have only two tables, so the previous tables have been dropped because we did the schema override. I mean, we just removed the previous example, created a new example here, and did the migrate run. So what will happen? It will say, okay, now you have only two entities. It will drop the rest of the entities. So you can see on the top, we have actually dropped all these things because we actually cleaned up the schema file. This will obviously happens. Okay, you define the 5 models, and in the second go you didn't change the you didn't update the models, you removed the 5 models and introduced two new models. What will happen? All the 5 tables will be dropped because it's like incremental migration is getting created. So you can see all these are dropped, and this has created these two tables with all the relationships which I have added. Now let's say if I'm creating just I'm even again going to remove these. So what will happen? Let's say I just take the backup of this, and what we'll do is I will just create two another, and this time it is a simple author. Okay, author is the model, ID primary key, name is fine. I will just have a name which is of type string, and this is author, so I can have a simple relationship. Here I have a quotes, and I do have another model as a quote, and this can be author, and I do have another model this. So this is going to have like, okay, author ID is going to be of type string, and I'm going to define the relationship one to many because single author can publish multiple quotes. So it will be author, and we will define all the relations fields first. So the field is author ID in this table, and the reference to the ID of the author table, and unique key we don't need this relationship, this constraint, unique key constraint. Now I just created these two another entities, you can see. Okay, here it can be the constraint name can be a different one, but it's like there are two new models I have added. Now what will happen when I just run the migration? It is going to wipe out all the existing tables. Npm run prisma generate, it will ask me the name. Okay, this is the new migration it will generate, and then it will actually remove the existing tables we have and just keep these two only. Currently Prisma supports only one single schema.prisma file where you have to define all these things, all the models. So I'm creating another migration with the name of authors, and you can see this here, and based on the changes it will do that, and you can see it has dropped the account users and user bank accounts. Now we have actually two new entities, two new models. Create new double quotes, create new table author. So this is how it works. You reload this, the existing tables are gone, and you have these two new tables. Okay, so this is all about just playing with the Prisma migration, how it works, and the Prisma generate. You can actually now generate the clients for these two models, and then just play around with the different methods provided by Prisma client APIs to find all, remove, update, delete the data inside the tables. Hi everyone and welcome back. Welcome to my fourth video on Prisma. This is like the fourth episode, not the first one. Okay, so in the previous episodes, we have already seen how to set up the Prisma, how to bootstrap a simple Express TypeScript app, and then we explored the Prisma schema by creating a different type of models, user, blog post, uh, banking system. These kind of schema models we have seen, and we have executed the Prisma migration command, which is generating the real tables in the database, and we have explored all those things. Now this is the time to actually see the Prisma client APIs to access the data, insert, update, delete, find, all these kind of operations we are going to explore. So I'm starting a very fresh project which is totally empty, and we are going to set up everything from ground zero. So what we have to do is we don't have package.json, we just have a prisma.schema in this, and this project is uh, Express Prisma Postgres API. So we are using Postgres as a database, Express as the framework, and Prisma is a ORM layer. What we will do is npm init, and we already know that what kind of dependencies we need. So we'll just install all those dependencies. Instead of installing one by one, we need Prisma client, and all the other dependencies which we need to run a simple Express TypeScript app with the testing through the jest, with the linting and formatting with the prettier, testing with jest and .env, all these kind of different modules we need. So I will try to install a couple of them, and then we will go from there. Npm install --save. First we will install the Prisma dependencies. So first is Prisma client, the latest one, and we will install Prisma. Okay, then we can install Express. We are going to use some kind of a simple login system, so we can use Express JWT. Then we have a JSON web token, and rest we will install whenever we have a need. Like I also have another dependency related to Swagger. Okay, Swagger UI Express, that we can install. So these are actually code dependencies. Rest we will keep installing whenever we need them, and then rest all are typings. Okay, so I will just open another terminal, and from there we can install Express, Swagger UI Express. This is another dependencies which we will need to expose our APIs. Okay, and then I can install a couple of dev dependencies, like okay, the types node, types express, types all the typings. Okay, so I will just type npm install --- dev, what all types we need: types express, types node. We are going to use jest also, so jest as a dependency and jest for the types. Okay, types JSON web token, ESLint, and couple of more. I don't want to install all the dependencies like this. I can just use rest all the things from my package.json. Okay, once we have all these dependencies set up, like we also need TypeScript because we are going to write Express TypeScript project. So what I will do is I will just simply copy my template, like the package.json, which contains all the dependencies related to the pretty-rc, all the ESLint dependencies, TypeScript ESLint, TypeScript ESLint parser, types for JSON web token, types for jest, TS jest, TypeScript, TS node dev, all the dependencies which you can see in any Express TypeScript project. Okay, so what we will do is, let's see what we are able to populate in the package.json. So we have all these dependencies coming up. We have the Prisma. So now we need to add the scripts related to okay, how we are going to run the application. Like we can use ts node dev, we can use nodemon, we will be using TSC TypeScript compiler to build the code. We are going to have a tsconfig file in the project, and all the other npm scripts related to the Prisma, like Prisma migrate, Prisma format, Prisma generate, Prisma studio, Prisma reset. All these, Prisma reset is actually to reset the migrations. Prisma format to check the formation and expose any errors if we have done in the writing the Prisma migration, and Prisma migration to actually run the migration. Prisma generate to generate the client, and Prisma generate watch, like sometimes what happens is you keep changing the models frequently, so you can actually use Prisma generate watch. It actually checks your models and it applies those while creating the new Prisma client. Okay, so let's do that. I will update my package.json, and then together we will update all the npm scripts. So I have this basic setup. I have all the dependencies added. So what we can do is simply npm install, and now we are writing TypeScript project, so it's not straightforward. We need to have a TypeScript compiler and tsconfig file, right? So what I will do is I will copy the tsconfig file here, which will help us to build the code. And you can see it's like a tsconfig template I have, and it is going to just build the code and put all the code inside out directory dist. Okay, and we can use nodemon, which is going to use ts node to compile the project. Npm install --u -dev nodemon and ts node. These two dependencies you can add, and then you can create a nodemon.json. Almost all my projects I use nodemon. Nodemon is really nice tool to set up your projects. Now with the nodemon, what do we need? We just need to have a nodemon.json, and it will have the location from where we are going to start the project, and it is using ts node to bootstrap the application. First get the npm install done. So we will just use the nodemon.json, and what we are going to do is we are going to start the application, and we are going to create a src folder. There we are going to have index.ts file. So let's create a folder source, and there we can have an index.ts file. Okay, now I can update my package.json so that it starts using nodemon for running the application locally. I mean, on the production we will always use node and the compiled output. So here you can say, you can do start dev, and you can just use nodemon command. That's it, and let's wait for this installations to be done, because we have done npm install. Once this is over, what we can do is npm run start dev. It will use nodemon. Nodemon will use nodemon.json. It is already using ts node to run the project. Ts node will also look at the tsconfig file, and I mean, it's like a watcher. It will keep watching your source src folder, and if you change the code, it will again restart the application. Src index.ts. So if I just run this now, npm run start dev, then it will break because our npm install is still running. And here I think this is already done. Let's do this. Start dev. It will use nodemon for compiling, and currently we don't have any code, right? So let's say source index.ts. It's nothing, but we will add some code here. And inside this it will just put the compiled output. That's it. So we have just basic setup ready. Now we will start adding the express component, all the additional files like the prettier rc, eslint rc, eslint igno, .env files, all the environment files, tsconfig we already have. So I think now the basic setup is ready, right? So let's cancel this and let's focus on our entities. We can kill these terminals. Now let's come back to Prisma and Prisma scripts we have added in the project. So you can also add a simple build command. I mean, this is already happening after post install, but this is fine if you add this. So npm run build, it will just use TypeScript build. TSC is TypeScript compiler, and it will just generate a dist folder. And npm run start, this should be the start prod, because here we are actually running the compiled output. Now looking at the Prisma, first of all we need to check, do we have container running? If container is running, that's a good news. We can just focus on writing the Prisma schema file. Okay, it's running. So what we can do is, let's focus on what all different entities we want to have in the project. I want to have a project where I can show the different relationships. Like I'm going to have some kind of a blogging system. So schema.prisma, and here I will start adding. We have already seen a couple of examples, right? So same type of examples we are going to add. Like we are going to have a user, comments, tags, articles, all those things. So we'll try to start modeling one by one. Model user, and here ID, which is int ID, and default is auto incremented. Similarly, we'll add email, which is of type string, and it is unique. I think it's a good idea if I copy all those things from my previous example, previous demo which we have done. Password is also of type string. Okay, and the profile image, which is of type string but can be a null. So if here also you can also put some default value if you want to have, like some URL, https google.com me.jpg, something like that. And then here, because this is a user entity and what we are trying to build is the blogging system, so we are going to have articles, tags, comments. User will be writing articles where people can add a comments. You will be able to tag the articles, right? So first of all, let's model our article, because article is the root. So first is the article model, and here we are going to have a couple of, we can copy something from here. ID is auto incremented. Then because articles will have a slug is a string, non-unique, and title, description, all these properties. Title, description, created at and updated at, and I think we already have something like updated at. Let me just check. Yes, in the last video we used that. First of all, we'll just need to specify the type, date, time for both, and then we can specify some default, default updated at that we can use for updated at, and this is the default value for this is now. This is really helpful. I installed one plugin related to Prisma and I can auto complete a lot of things. Now the article will have the author, article will have number of tags, article will have the list of comments, right? So article is kind of a root entity which will have a relationship with the most of the entities. Okay, let's say the tag list. So tag is the another model we are going to create. We have author, which will be a user because somebody is writing it, and here we can actually create a relationship with the relationship name is user articles. These are the user articles, and the field for the reference is the author ID. So here we are going to create author ID as an integer, author ID, and that is integer. So this is the reference. So this is the field, and here we are going to create the reference for this. Reference will be the ID, primary key of the users table. So you see, I mean, I just added the relationship name here. The fields in this article table is author ID, and it is referenced with the ID primary key in the user entity. Okay, so this is our author ID, and then this article may be tagged as a favorite, but I think those are the advanced features which we can add later. We have comments, which will be pointing to the comment model. Now we have a tag and comment, two other models. Let's structure them. Model tag, that's a tag list, because one article can have a multiple tags, and we can copy a couple of columns and change the names. So tag will have a ID, then it will have a name of the tag is of type string, article, and it will point to a multiple article array. This is sorted, and then we have comment. So comment may have a couple of more things. Model comment, I mean, you can also use the other attributes like @map, that is going to help you to actually change the table name. Let's say it can be the post tags, something like that, right? That we have already seen how you can use them. And now why it is complaining? Okay, I'm adding comment, and comment will have the same ID created at, updated at. So first of all, the default columns, you can use either the snake case and use it the same everywhere. Date, time, default now. This is the ID. Body, comment body is of type string, like what comment you are adding. Then we have article ID. To which article you are adding a comment, that is of type integer. And now I will define the relationship here with article, and here is the relations fields. The local field will be the article ID. Local field is article ID, that is referenced with the ID in the article table. And then I have the author, because if you are adding a comment, then there is an author, somebody is adding that comment, so it will have a relationship with the user relations, and the field will be here the author ID. So same as article ID, we are going to have another column, that is author ID. Now, I mean, for me, like writing these are very easy, because after writing couple of examples from scratch, it is able to identify what should be written here. Okay, and it is referenced with the ID in the user table. So this is author ID is integer. Okay, and author ID is integer. Why it is complaining? Author relationship with the author ID, that is fine. And now here in the comments, I think we mismatched the names. Here article has an author, comment also has an author, relationship with author ID. Author ID is integer, reference with ID. So let's see what is the problem. Either run the Prisma format or add it manually. It's better if I run Prisma format, and it did some magic. Okay, so few things were missing from the user, because if you undo this, we don't have these things inside a user that I was going to add. Like user was the first model we started, but we also need to add the associations back to the user. User will have article, relationship with the user articles, and this is article, this is comments. Then we have, I think these are the basic relationships we have added. We can groom it a little bit more, let's say, because what we are doing is user can have couple of more columns, like the favorites, like you mark some favorites. What will be the favorites? Favorites are nothing but the articles, right? Relationship is, and this can be the user favorites. And here inside an article you can define the another relationship is, in the article, is favorited by. Favorited by, sorry, and then this can be a user favorites. It's going to be the reference is going to be the same. Reference is the ID, and inside user we are going to use this relationship user favorites. Okay, now inside user what else is missing? You can add the favorites followed by, let's go to the user. We have favorites followed by, so we can add couple of more relationships, because user may have been followed by and maybe following something, following couple of more users. So here let's copy this, and here I can say is followed by and following. So it is going to relationship with the user array, and you can put some relationship name and then reference that with the ID. It's like self references we are creating. You understand? Like this user is followed by a couple of another users, so it's like a self relationship. Here you can say user follows same relationship name. Okay, now let's see. Now we have everything sorted. I think this line is not a valid field or attribute definition. What is wrong with this? Is that one comma was missing? Yeah, everything is sorted now. You can see our models. Now let's take a look back onto this article. User is writing an article. We will also see this on the relationship layout, like how these one-to-one, one-to-many, many-to-many relationships are created, and what is the meaning of these relationship names which we have started using. Okay, so article will have author, article can be favorited by, article will have a comment, article, so all the things we have added here. This is the author relationship. Article may be favorited by or bookmarked by some user, and article will have a list of tags, article will have a multiple comments on top of it. So here we have a relationship with the user. Author ID, which is of integer, so this is the foreign key in this table pointing to the primary key ID from the user. Same here. Comments will be pointing to some particular article, so comment will have a foreign key article ID, right? Or it will be written by some user at the end, so it will have a foreign key user ID in this, like author ID here. Author ID and the article ID both are integer. Tag will have like a single article can have multiple tags, and one tag is pointed to the multiple articles, so it's like many to many. User will be writing the comments, user will be writing the articles, user will be followed by some other user. User might be following some other user. User will be writing the comments. So all the relationships are defined here. Now it's important that where you are going to define the array relationship and where you are going to define the relations. Okay, let's go into the deep dive into this, run the migrations, and then we define the relationships through the ERD diagram of the Postgres. So what is the next step? Running the Prisma migration, and here we do have env file. I have Postgres container running. What I will do is npm run Prisma migrate, and what it is going to do is it is going to migrate. Before that, we can just do all the other commands. Format Prisma format, its format, and then after this we can just use Prisma migrate command that will do the real migration. Everything is fine. So here we can just execute the migrate command. It will use this .env file to check our database. Where is our database? And then it will run the migration against that, and we will have all the tables ready. I wanted to wipe out the existing data structure, whatever we have there, and it is creating the new migration for me. And here we can just see that migration. I mean, you can also put the migration name. I skip that, otherwise it will create a migration name. And here we have all the tables. Now we can see the major tables. We have article, we have comments, we have tag, and the user. And then all the relationship tables have been defined here, like article tag many to many, user favorites, I think it's also many to many, and user follows. And here we are defining the constraint. So these things we can understand from the tables, like what all. Okay, these are the tables. You can see the created, and here you can see the structure of the user. This is unique, and we have the primary key, foreign key. This is user as a primary key, and all the other relationships you can see user favorites. So it is you can see article.id, user.id, user favorites. Like user is marking one particular article favorite. So here we are creating many to many relationship, putting the user ID and the article ID relationship. Here we have user follows. So it is the user, it's a self join, I mean the self relationship, another table which is having two different IDs. Okay, this user follows that user. So it's like another third table which is managing the, okay, this user ID follows these 100 users. So this will have 100 records in it. User favorites, article to tag means one article can have multiple tag, and one tag can have multiple, can be added in the multiple articles. So it's like many to many again. And here you can see article.id and tag.id inside this many to many table. So here we have, you can also check the DDLs and all. I can check the DDL of other major tables. Here you can see create unique table, unique index, and we have some references. In the article there is author ID, and if we see the comment, inside the comment we have author ID and article ID as a foreign key. Okay, so this is it, guys. We have executed the migrations, and now we have everything ready. Now what is the next step? Writing the APIs. First of all, generating the Prisma client, and then writing the APIs. So for generating the Prisma client, we can just execute the simple steps. We already have the command ready with us inside package.json. I think it's a Prisma generate. Prisma generate, and you can also execute Prisma generate watch. It will keep watching your models. If you change them, it will automatically update your Prisma client. And here we can also expose the Prisma client. It's not like we always need to look into node modules. Here I can create a Prisma client, and I can add that Prisma client in the global object of Node.js. So what I can do is, I will talk about this, how we are planning this Prisma client.ts. First of all, we will see the Prisma client which has been added in the node modules. Prisma, and here we do have Prisma client definition. and here we should have okay articles, all the entities, all the models are there inside Node modules, and it is exposing all the methods of the Prisma APIs. Okay, prisma.article.find many, find, save, insert, update, delete. I mean the normal CRUD operations. Here I wanted to add the Prisma client object into the Node.js global object, so we don't need to do new Prisma client and all. So this snippet is provided by let me just see how we can do it. Where we have Prisma client, and this is provided by the Prisma documentation itself. What it is saying is you can assign the Prisma client object. So if global.prisma is already there, do not do anything, otherwise create a new Prisma client, and this Prisma client you can assign in the global object global.prisma equal to Prisma if this is the development, right? So what it is doing, it is preventing the multiple Prisma client instance that might not be a singleton. So what we are doing, if you are on the development environment, we are checking if in the global we already have Prisma, then assign it and then add that to the global.prisma, and then we can just use simple global.prisma users, global.prisma.tags, global.prisma.comments, all these different APIs. Now we are going to write express MVC style of controller services and all. We can also add some configurations like ESLint and all those things I will just add. Like we have a couple of files, I will just add just config and all. So this is my ESLint. We already have ESLint files, ESLint dev dependencies, prettier RC, just config. We can write some test cases. Okay, so now we can just get started in writing our APIs. Inside source you can create controllers, services and all. Controllers, models, then we have services. We can just create some skeleton, then we will fill that up. Utils and the express routes, and our index.ts we already have. We can also create one test directory because we are doing end-to-end setup, and we are also going to deploy this to, let's say, Heroku, if we are able to find the Prisma instance there. Okay. Hi everyone and welcome back. So this is part 2 of our previous video. That was part 1 where we created a baseline structure for the Prisma APIs. We wanted to create a blog APIs where we have the entities, users, comments, tag, articles, all those entities. And now we are going to use Prisma client APIs to run all different kind of database operations. Before that, let's take a look on some documentation. And here we have Prisma models. This is how we are defining the relations in the Prisma model. You can see the user and the post that we have already done, like one to many kind of relationship where user can write multiple posts. So this is how you will define the association. Here author ID will be a foreign key in the post table referring to the primary key ID of user table. Okay, and then I wanted to see what Prisma client API provides, like simple CRUD operation where you can do insert, update, delete, like create, read, update, delete. So first of all, how we do create. So prisma.user.create, I can zoom it a little bit, and then let's say I wanted to do something more than that. So here inside create, you can just define the post, right? And you can also include the post, like user has a post relationship, so you can also associate post there. So it will create a user first and then it will create a post. Create multiple records, you can do a create many. So the first API we can understand like prisma.user.prisma.entityname.create, right? And then there is another API in the Prisma client, create many. Okay, so now if you wanted to read, like if you wanted to do find unique, and this is the where clause. These queries are kind of similar which what you have done in the SQLize or the type ORM. You are passing the where clause where email equal to this, and it is doing find unique. Find unique by ID. It's like find one by ID. Okay, and here like this is the composite key we have, and here you can do composite find like prisma.find unique based on the year quarter, right? And here you can specify the parameters. So it's like compound ID. You wanted to do a where clause with year and the quarter, right? And here you can specify the unique constraint time period ID. So the same constraint name, because here I have seen the lot of alias happening in the Prisma model also. Like here I put the unique constraint name as the time period ID. So I can specify the same where time period ID equal to this, right? So to retrieve the time period by the unique qualifier, we can also use this custom identifier name. Get all records, it's like find many, specify null, specify empty where close, find first. Now here you can see the nesting. You can see prisma.user.find where post had some likes greater than 100 and order by descending, right? So it's like some kind of filtering is happening. Here ends with find many where email ends with prisma.io, like we do like query. Similarly here we can actually do starts with ends with, and then find by multiple fields. Like you can also do the nesting of and or, like SQL queries is something like select star from this table where this equal to this and this equal to this and this equal to that, right? So here what we are doing, this is an array. That means this is an OR condition. Do we have SQL generated for it? It's like find many where name equal to name starts with E and profile views greater than 0. I think these both clause are AND clause. And so what do we have here is these two clause are inside OR. So it's the query will be like this: select star from user where name starts with E or profile views greater than 0 and role equals to admin. So this is the AND clause. For both, this is the OR clause. OR clause means the outside is the OR and inside these two properties we have AND clause. Okay, so here also you can do select. Okay, this is the condition where clause, and I wanted to select only particular columns from the select query. Like this is going to return only email and name. Okay, I think we can also get the CLI output for some of the queries. Here you can see what it is going to return. Here we are doing email, and then this is like user and the post. So what we are trying to do is we are trying to get the email, and the post also should be there with likes true. So user has posts, right? User already has a relationship with the post, so you can actually do the nesting select, right? I mean posts is not inside a user entity, but here we are actually fetching it's like a lazy loading where you can actually define the, if the ref association is already there, you can get the data from another table inside the same query. So email, posts, these are the likes because we are selecting only the likes for these two records. Okay, here you can also include true, like if you wanted to include the another table data in the same query like prisma.user.find many, if role is admin, return those and also include the post for those all users, right? So what it is doing, you can see it is returning the posts empty, whatever the post this user has submitted. So you don't need to do much of thing if you wanted to include the foreign key table data inside the original query. Then simple update, this is the where clause and this is the data. Simple. Using update multiple record, update many, this is simple update and this is the update many. Then we have upsert. right? So what it will do is upsert, if the record doesn't exist, it will create it, otherwise it will update it. Delete, simple delete, and then there is a delete many. Delete all the records, you can just do delete many, keep the clause empty, that means it is going to delete all the records. Delete with where clause. Okay, so this is all about the Prisma client APIs, and we are going to use these all different methods: delete, delete many, update, update many, find, find many, find unique, insert, insert many. All these Prisma client APIs while writing the APIs. Here, the last thing we can talk about the select and the filtering. Like this is all about select and filtering. So here you can specify the filter condition, which we have already seen these kind of queries. And you can also do aggregation, pagination and all. Relation queries, if you wanted to fetch the data of a relationship table, you can do includes API or the select API, right? This is called the eager loading, means while fetching the primary key table data, you wanted to fetch the reference table data. This is eager loading. I mean, most of the time we don't wanted to fetch the data from the foreign key table, but eager loading means from the primary source return the data in the nested object. So there is a select API or the includes API. There is select API and includes API for that. And we have a couple of more things: pagination, aggregation, grouping, transactions, null, undefined, a lot of things. We will come to that when we are writing our APIs through these CRUD operations, articles, users, comments, tag. For those, we already have created the models in our code base. So now let's create our application. So we already have index.ts, everything is set up. We just have empty folders. Now we can start creating Express server. So first of all, we can import Express, and we are writing Express type script. So we are importing Express from Express, couple of more modules. I mean, we have used this kind of code many times, so I will not focus much on explaining things. We got the Express instance. Then we are going to use some couple of middlewares like chorus middleware, cross origin resource sharing. For that we have to import this. Okay, and we have to import routes. We will create inside the routes folder. Let's say inside routes we have routes.ts file, and then that's it. So we will enable all the middlewares, like we can use a body parser. I mean, body parser is now deprecated. We can use express one only, like simply express.json. This is same as the body parser, registering body parser app.use, and we will register all our routes. This is how we do it. And we can also set the public directory, and this is express.static, the directory name. I mean, if you have any public directory, you can specify that here, and then app.get, just a simple hello world kind of. So we have a request is of type request, and then we have response, which is of type response, and here we are just saying response.json. Here we can set status with just a simple message: API is running. It's kind of a health check endpoint. And we can import request and response from Express. Cannot find. Okay, this is a callback. So simple, we have created Express app here, closing this and that, and we have to listen to a particular port. We can also use a Swagger UI Like if you have a swag, I mean, that depends on us. If you wanted to write a Swagger YML, Swagger UI from Swagger UI Express, and then we can actually write a document endpoint that will be app.use API docs. It will serve this Swagger document. And now finally, we also need to import the Swagger document. This is nothing but a JSON file, Swagger doc from, let's say we have document. We can create a document actually outside. So let's say we have a JSON file there. This is just optional. If you wanted to expose your APIs through Swagger YML, then this will expose all your documents from there. And we will just create a simple sample document there inside Swagger YML. Inside document we can put a empty Swagger JSON. So here we have, okay, now we need to just start the application by listening to a particular port app.listen, and we can also add on to some error handler middleware, right? So we can simply say app.use, and this is just a middleware function which takes error request response, right? And what we wanted to say here is just like expose the error codes. If we are not able to intercept any other error, then return 500. Okay, now we can just listen to the port app.listen with the callback onto a particular port. I'm just doing a copy paste because this is, we have done this many times. And HTTP exceptions. So HTTP exceptions we can create, let's say inside utils I can create http.ts. It's nothing but an HTTP exception. We can create our own custom extends error. So this is just a simple HTTP exception class which we are exporting from here, and then here we will import that HTTP exception. This we can import. Next function is part of express. Now we need to define the routes. Okay, like we are going to have a user routes, article routes, comments routes, and tag routes. So inside routes, let's create routes.ts file. So index.ts, here we have routes.ts. Right, currently it's empty. We will use the express router to define all the routing. Router from express, and from this we are going to export default router instance of router, and we are using, I mean, we are just putting global prefix to all the routes API. Okay, and now I can create API router, const API equal to router, and here we can say router.use when we are talking about all these things. So I can have like all the other controllers. So I'm just having auth controller. So because I'm going to create a user APIs first, which is like create user, register user, login user, and all these things. And I can create auth controller, import auth controller from. So we have to go outside, and then there is a controllers, and then there we will create auth dot controllers. That's it. Similarly, we can create other controllers and we can create chain here, like app.use some other controller, let's say article controller, right? And here I can specify that this is just another controller from, let's say I just put another name. Okay, that's it. So here I have created my routes, and then we need to move to the controllers, and inside controllers we can create our auth.controller, auth.controllers.ts. And similarly we also need one more controller just for an example, article.controller. So inside controller, add new file, article.controller.ts. Okay, now auth controller is all about some APIs related to the user. So how we define the routes and all these things, right? So here const router, I'm creating the instance of router here, and I will export the router from this file. I mean, all the controllers will follow the same syntax. This is same Express application. I'm not doing anything fancy here. And we can get the router from Express, import router from Express. Other than that, we will also need a request response and let's say next function. Okay, now we can define all our methods here. What all methods we have? Router dot, here you can put get, put, post, delete, router dot post. Let's say my first route is create users, which is, you can call it as a sign up. Okay, and here async. Here I have a same request is of type request. Let's say request response and next. There is a callback, and here we will do stuff. Okay, and we can specify the type. Request is of type request, response is of type response, next is of type next function. So it's kind of a template, we'll use it everywhere. And here I always prefer try catch because it's a async function, can throw something on us and we have to catch it. And if it is throwing, then just next error, because we already have a middleware, error middleware to catch this thing. And here we are talking about users. So first of all, I will get something from request.body, and then let's say I can call create user, and here create user, I have to define this method, and I will be passing request dot body. Inside that body we are passing user object. Okay, now this create user, we can create a service. Let's say I'm creating auth service here. Auth service.ts, there we will define this method create user, so it completes the end-to-end flow. I will just import this thing, import create user from, go outside, inside services, auth service.ts, there we will define it. So if we are able to create the user, we got the user object. So what we can say is response dot json, and I will just return this user object, and this is async await, right? So create user is the method we have to define inside a service, and that will deal what to do with this request body. We can also do the joy validations for this payload, that okay, all the required attributes are available in the payload, and then only you will be able to create that. It's like simple express MVC app, which you might have already done it. So I'm just not focusing much on the logic part. And here inside auth service, we can create our method like, what is this, export const create user, and it's async method, and you will get the input object. Input object is of some type, any, let's say, and we will add some typings later once we receive this thing. So create user, we are already exporting this async input. We can create some models in our models folder. Let's say the register input is our first model. So inside that, or you can call it as auth.model.ts. Inside that we can create a simple register input, export interface, and in this payload we wanted to have email is of type string. It's like an interface. Username is of type string. Password is another attribute. Then we have image, it's an optional of type string. Bio is an optional of type string. Okay, and this register input is something which we can use inside auth service, considering that this is the kind of input we are going to get. And now once we receive all the parameters, what we are going to do, we are going to just use the Prisma client and store this data. So here const.email, we can just say input.email. You can do trim, you can sanitize it, and all these things you can do. Same I can do for username and password. So these all things are required. I'm just worried about only the required things. Okay, then we can do the joy validation and all these things, and then finally we can start creating the user. First of all, we need to create a hash password of this user, because we are sending the password in the body. So we can use the bcrypt library. For that we have to import the bcrypt from bcrypt.js, because we have to create a bcrypt version of the password. So here I can do bcrypt dot hash, and we are passing the password, because this we are going to generate the hash for the password. Hash password we are going to save const user, and now we can just simply do is const user Prisma we have imported from the Prisma client. Await Prisma dot user dot, we have all the methods. I'm talking about create here. You can see these are the Prisma client API: create many, find first, find many, update many, and do we have something like save? No. And then we can see all these things: group, update many, find, delete many, delete, create many, create, count, aggregate. Here we are talking about create. So inside create you have to pass this object, and inside this object you have two things: data, that is actually your payload, and if you wanted to select a particular things after your insertion is done, you can specify it here. So inside data you have username, you have email, you have password, which is the hash password. We have converted that, and let's ignore the optional properties. And once that is done, we can return email. You have to specify them as a like this: email true, username true, because I don't want it to return the password which has been saved. So I'm just returning only email and the username. Once the insert is done, And after everything is done, what we can do is we have to return the token, right? So this is the user object, and we can generate the token. So we can call the method generate token, or let's keep it like this. On sign up, it will just we are going to return only the user object, but when you are doing login, we will generate the token if the login is successful, right? So now in the same way, we can create our login, and we can use that login from our controller method. So here export const login, and here the payload will be, let's say, any, and we inside this we are getting the email and the password. These are the two attributes we are getting. We will add the proper typings and all. Here we are just talking about the logic, right? Now here, instead of prisma.user.create, we will do find unique, right? Because we want to match the username and the password. First of all, find unique where, because email is unique in the database, where email is whatever we are passing. Just remove this close. So it's like the where clause we are adding. Now if this is true, after this you can select a particular properties. I wanted to select email, true, username also I wanted to return, and the password, because password match we have to do that. We haven't done the password match. So from the where clause we are returning these 3-4 properties, and here we can say if we got the user object, that means user exists in the database. We have to create a match with the password for the password. So here we can just do is bcrypt.compare is the method, and here we are comparing the password which we got it from the payload body and user.password. And if both are, if we found the match, then what we need to do, if we got the match, that means user exists in the system with the exact same email and password. So we can return the required things from the API. We can return the email. Okay, email is user.email, and here username, and we also have a token property. So we are calling generate token from somewhere, and we are passing the user object. So it's all about like how to generate the token when you are passing some kind of a payload. You can use some kind of a secret key and the expiry, and with the help of all these things you can generate a token. So here I am using one utility, and inside that we can create that method utils. Let's say I'm calling that as a token utils, token utils dot ts file. That is nothing but, okay, how to generate the token using jwt.sign, your user object, secret, and the expiry. Okay, let's keep it any, or we have to define the user model first. User model contains all the attributes about the user, because user model we are using at a lot of different places. So let's create a user model. I mean, in TypeScript it's better to define all the models. User.model.ts, and here we can say export interface user and define all the properties. ID is of type number. I mean, it's all about all the columns which we have added in the database. This is of type string, that is required. Email is required. Password is required. Rest all the things, like we have optional properties, let's say bio, which is can be string or null. Image, that is also can be a string and null. And other relationships, like we have articles also, those all the other model properties we will add. Export interface user, so we can specify, we can import this user model here. That's it. So we can call this generate token method from the auth service. We have to import it. That's it. So this is all about our login and register, right? So you can see what I mean. We have done this kind of a code hundred of the time, 100 times. I mean, it's not like first time you are writing express controller and receiving the payload from the request.body and saving into the database. It's all about like how to do the same thing with the Prisma. Here we are doing just calling the create method after generating the hash password, and here we are doing the find first, find unique based on the email, and if the email is unique user has been received, which is not null, we will compare the password. If password is also matched, then we will generate the token and return this payload to the user. Okay, so now let's plug in the APIs with the router. Here let's add a couple of APIs. First is register, another one will be the login, right? And then another one we can have is post login. When you are trying to pass the token in the header, then you can also call get your own user data. Okay, so I can have get user. Another thing is users login. This is HTTP post, same request response, and here we are passing request.body.user. I will use login, which I will import. Okay, I think this is imported. Then current user, so here we will call another method is get current user. Now you might be wondering like how we can get a user data. So what we are doing, what is the flow? Simple is a sign up. Okay, you know your username password, you will do the login, you will get the token from that, and then you will just hit any other protected API. When you hit any other protected API, in that case you will pass the token which you received as a bearer token inside authorization header. Okay, you will send this inside authorization header, and then protected API will decode the token, and it will extract the user from this. So we will know who is the current logged in user. I mean, this is the same flow you do with auth 0 or any other kind of a login mechanism. You first do the login, you get the token, you pass the token in the authorization header, we decode the token, check the validity of the token, and from inside the token you get the user metadata. So with the whole process, if user is logged in, user token is valid, at the end you are able to capture the user information, and from that you will know, okay, this is the logged in user, and you can return the logged in user data. So here the last API is get current user. We will decide what how we are going to deal with this. First of all, we have to create one middleware. What that middleware will do is that middleware will check which API is a protected API, which API is a public API. For us, let's say the user registration should be a public API, login should be public API, but when you're trying to get your own information, this should be a protected API. So here I will create some middleware. Inside our utils we can create that middleware. That middleware is, let's say, auth.ts, and I think I already imported express JWT. That middleware we can use to create a auth middleware. So const auth Here I do have, let's say this is required, so I can use JWT, which is coming from express JWT. So this library I'm using to validate the token, and this is already providing this middleware. You don't need to do a lot of things. Inside JWT you pass the object, and what all things you need to pass. You will pass the secret using which you have created the token express.env, process.env, jwt secret. If you don't have, then I am just passing super secret. Okay, first argument is a secret, then another argument is a token. We have to pass the token. And how we can get the token? We have to define one method which is going to extract the token from the headers. And then algorithm, I mean, if it is a TypeScript we have used, then it would have been easy to pass all the parameters. These are 3 parameters, okay. And then another is we have function which we need to define, const get token from headers. So here what we are doing, let's say const get token from headers, we have to return the token, okay. So token is in the form of bearer token. So here we are getting request. Inside request we have headers. Inside header we are looking for authorization, and which is of type string, okay. And this will return either string or null. I mean, we are writing TypeScript, so it's better do it in the right way. So what we are checking, if there is a request dot headers dot authorization, if it is there, request dot headers dot authorization, then what we need to do is we can return request dot headers dot authorization dot split, because they will be separated by space, bearer space token, and I will return 1, otherwise I will return null. You can do the checks, okay, it is following the regex, because the token authorization should contain something like this, bearer space your token. So here we are doing this is the auth middleware, and you can pass auth dot required wherever you wanted to protect the route. So let's go to our routes. Inside auth controller, if I wanted to protect this, then I can just use this. So here, from here we are doing export default auth, and inside controller we are importing it. Auth, what's the problem here? Okay, and auth dot required, that means this is required, and we have added this middleware that will validate the token, and it will decode the token, and it will populate the user object inside the request object, request.user. This is what it does. So now I can use this API for that. So get current user, and I can pass request.user.username. Okay, and this request is of type so we have to customize the request. So sometimes we have to actually customize the request object. So what we can do is we can create a .d.ts file, user request.d.ts, and here we can say, okay, inside we are already using the namespace express and we are overriding the definition of request. It may contain user and dot username. Okay. This works now. After declaring the type definition for this request object, request.user.username, and we have to create this get current user inside our service. So we go to auth service. Inside auth service, we will be calling export const get current user. Get current user, it is doing a sync, and we are passing the username, which is I think unique. Async username, and we will do all the other things here. Let's say const user, and we can do await prisma dot user dot find unique. This is Prisma client API we are using, and we can specify the where clause where username is username. Okay, and if it is found, then select all these properties. So we are selecting only email is a true, and just return email and username. That should be enough, and we can. So after returning this, we can return the user. That's it. It's just like, okay, I'm logged in user, give me my user object. That's it. And this is being called from the controller user login, and here we are doing get current user. String undefined is not assignable to type string. I think this will always be there. So get current user, this is always expecting a string. So what we can do is, let's go to our controller, get current user. Here we can just typecast it as a string, and this should solve our problem. Request dot user dot username. Yeah, this is okay. So we created a simple auth APIs. Similarly, let's create an article controller. Inside article controller, because here we are going to do a lot of things. Once user is logged in, you can fetch all the articles. You can also fetch the articles by the logged in user, right? User is already logged in. We already know the username of logged in user. So you can fetch all the articles of the logged in user. Okay, now let's check our article controller. What we will do is, whatever we have in the auth controller, we can simply copy paste that, and we will change the routes in the article controller. So article means create article, update article, delete article, fetch articles by the user. All these routes I do see, and we are going to have article service. So I will create a service also. An article service will look somewhat similar to the auth service, when it will be dealing with a different stuff, like it will be just dealing with the articles. Instead of prisma.user, it will be using the prisma.article. Okay, so in the article service we can talk about, okay, get article, create article, all these different set of APIs. So first of all is article. Let's see the create article, and it will have some input like article and the username, and it is going to have a username which is of type string, article is of type any. Okay, let's empty the body. Here we are going to create a new article. Okay, similarly that will be update, delete, add comments and all these APIs we are going to expose from this. So create article. Let's say in the article, in the request body, we are getting all these attributes. Attributes are known as, let's say, the title of the article, description, body, tag list. All these things we are getting from article, and it's type any, so it will allow us. Now we can actually add a joy validation, okay, that this all the required attributes are being passed or not, that we can do. And then I will be using so we are getting the username which is unique throughout the table, so we can call another method, find user by username, and just pass the username, because we need to know who is the user, who is what is the user who is creating the article, right? So what we can do is, in the auth service, auth controller, auth service, we can use either the existing method if we have, or we can create a new method. What will be the name of the method is find user ID by username. Okay, it is taking user ID, prisma.user find unique, and here where user name, here we just need to select the ID. ID is true, and here we can just check if we got the user, that means everything is good. Otherwise, if we didn't get the user, then things are not good. We can throw HTTP exception 404 user not found, an empty object or whatever. So just import the HTTP exception. I think we have created this class in the utils. If everything is good, we have the user object, return that. So find this we are getting from the service. Now go to the article service and just import this from the auth service. Yes, so now we got the user object. Now what we are going to do, we know who is the logged in user. Let's allow this user to create the article. And if you have seen the article websites, we always create a slug, and we use Sluggify. I think there is already a library we have imported, that Sluggify, based on the title and based on the user ID. Sluggify, we have the title and we already have the user ID. User will always be there. Sluggify user ID. Okay, so this is the slug name. Now we can see that in the article the slug name is unique. I mean, when you are writing article, you cannot have a two same name of the article, right? So what we do is, we'll just try to identify, do we have existing article? Existing article equal to await, then same prisma dot article dot find unique, and inside find unique you will pass the object like where close. We already have a slug, so just pass the slug. And I mean, in where close, you need to specify what you are trying to select. So select slug from article table where slug equal to this, right? So either it will be undefined, or either it will be some existing slug if you already have. So it is existing article. So what we will do is, we will just check if this existing article is there. If we found this existing article, that means we already have the article, you can go back, right? So what we can just do is throw new HTTP exception. It should be unprocessable entity. Okay, you can customize this. Errors, title, and you can just pass anything. must be unique, and just get the HTTP exception. Just a typo. Now we can just call the create method, because now we have everything ready. We have done the checks, we have the user ID and all. So const article equal to await prisma dot article dot create. Now you need to see that article has a lot of association with the other data, and we are going to pass a lot of data inside it. So data can be okay, the title is one, slug is another attribute, then we have body and description, and then the tag list. Now here is the important part. So tag is already an entity. First of all, it is complaining title article create input. Let's call it as a created article. Because there is a variable name conflict, and this is the data. Now it is requiring, okay, you need to pass the author, that is required. These are the required things you need to pass. That's why obviously the property author is missing. So first of all, the tag list. Okay, so now here there is a catch. Here tags are the independent entity, tags are a separate model. If we just see the Prisma schema which we have created, tags were considered as a separate identity table. And if we even see the Postgres table, okay, that's not there. Tags has a relationship with the articles. Okay, here you can see the tags, and there is an article to the tag. It's like many to many relationship. So what we need to do is, let's say I already have created 10 different tags. Now I wanted to associate those tags with article. So Prisma provides these utility connect or create. Let's use that. So tag list, we are getting this as a array of these tags which we are getting from the body. These are array of strings. Okay, so what we can do here is tag list dot map. Let's dot map, and here we are getting each and every tag as a string. And here we can, so what is this? This is the tag list, and inside that we have to create an object. Sorry for that. And inside this we can use connect or create. Yeah, this is autocomplete. That means either we can connect the existing tags which are already created in the tag entity, or we can create the new one, right? So here we can create tag list dot map each and every tag of type string. So in this we have to pass, this is actually a JSON object, it is going to return. Here we can do two things, either we can create or connect the existing tag. So name equal to tag and the where clause. I mean, I initially like this approach where you can actually either create the new one or connect the existing one. Similarly, we are going to connect with the author. So we have another important property is author, right? And here, because author is already created, we are just going to use connect. So these are the two important utilities I see in the Prisma, connect or create. So connect with the author, where the ID is user.id. So I have to do nothing. If I wanted to populate the author ID or author relationship or the tag relationship with the article, this is how I'm doing it. So this is our data, and inside this we can just specify what all things you wanted to include. Okay, once the insertion is done, right? So inside include I wanted to get the tag list, and inside tag list I wanted to select the name only true. This I initially I didn't like because you have to create a kind of hierarchy. Once the insertion is done, I wanted to include these things inside a response. From the tag list I wanted to select the name, and then from author, but these autocompletes helps. Inside author I wanted to select the username, so that will be true. Bio of that user who is writing this, and the image if we have it, that is true. This is all your query. So where it is opening and where it is closing, that we have to see. These are the includes, and this is the closing of the query. So after that, it is going to return the created article. I will not play with this thing, and I will just return the created article. Otherwise you can actually see what all attributes you wanted to return from this. Are we doing opening closing correctly? Okay, so this is create article. Now same way we can actually do get particular article. Like currently we are not, this is the article creation, we haven't added comments and all these things, but like once the user will see the article, he will be able to add a comments and all these things. So get article is another interesting method. Rest all is like plug this in with the some controller method. So we have get article, sorry, this method is get one article, and here you have to specify what is unique. Slug is unique, and the username, right? Because slug you are going to get the article by the slug name. Okay, I will just clean the body from inside this method so we can rewrite this. I was thinking to reuse some pieces from here. Get one article. Okay, so what we are going to do is, I have the username. Okay, so here it is going to be the simple query, const article equal to await Prisma dot article dot find unique, because there will be only one entry with this slug, and here we will specify the where clause, and here we will just specify, okay, based on this slug give me the article. Why it is complaining? Find unique where sometimes, okay, it was just a TypeScript thing. And once we are done with this where clause, we need to include some data in the response. Okay, so I'm saying, okay, give me the tag list, and I'm just selecting name of the tag is true. Okay, this is tag list first inclusion, and then we have author. From the author select username, username true. If you need some more attributes, you can just set them. It's kind of a GraphQL stuff, right? Feel like, not the exact GraphQL. Okay, you can select whatever you want, and then because further you will also add comments, so here you can select particular things about the comment, its comments. Okay, inside this what you are selecting is the ID, the comment ID, so you will set true for that, and then let's say the body of the comment, whatever the comment user has added, and inside that comment you also have author, and you can see this automatically populating. This is the beauty of it. That's why you don't need to confuse, okay, comments has the author, because comment will be created by some author, and then you can again do the select, which I I really don't like much, because here every time you have to select, okay, from this inner join, from the comments, if you wanted to populate user, then what all attributes you wanted to specify. I can just copy and paste username, comments, and bio. So these are a couple of attributes we have. There are a couple of more, but let's keep it simple for now. So these are the includes, this is the where close, and we can just return this article. You can do the transformation and all. So this is get one article. We don't need to identify, okay, find one user, because we are doing where close. We are not doing, okay, give me the article where the slug is this and the user ID is this. No. So this is optional. Inside this payload you can specify, okay, this author is this and all these things. So get one article, create an article, and let's test these methods. Okay, so let's do the testing of article controller. We have created two APIs, create article and get one article by slug, right? This is just I integrated that services with the controller, and this is our Prisma routes just for the demo purpose. Here I have article controller, and this is our article controller post articles and get article by slug. So while creating an article, we are creating some dynamic slug, and that using that slug as a query parameter, you can get that slug. Thus it is calling the same method, get one article, which we have written in the same video. Get one article and create one article. Okay, so let's see the demo. What we need is we already are a logged in user. We did sign up, we got the token, right? And we are going to use the same token here, because these both the APIs are protected. Oh, what I mean to say that is, in the articles you can see auth.required. It is using express JWTV. I mean that middleware that will just decode the token and will extract the username for us. We need this while creating the article, not while fetching the article. So here we can just test this. Let's say I want to do the create article. Let's say I'm just doing a POC Node.js.